Hey everybody, so this video is about the nitrogen cycle. Okay, so the nitrogen cycle is just like all the other cycles. It's just a way that nitrogen gets cycled throughout an ecosystem. Okay, so why is nitrogen important? Well, nitrogen is important because it's important to plants. Okay, plants have to have nitrogen in order to live, and as we know, if you don't have plants, you don't have animals that eat the plants, or you don't have animals that eat the animals that eat the plants. In other words, life on Earth could not exist as we know it without nitrogen. The good news is, though, however, that nitrogen is an element that makes up 78% of the atmosphere that we are in right now. So only about 20% of the atmosphere that we are in is oxygen, 78%-ish is nitrogen. But here's the thing. You would think that if we have all this nitrogen, 78% of the nitrogen in the atmosphere is, 78% of the atmosphere is nitrogen, then plants would always have as much as they need and there would never be a shortage. But here's the thing. So even though, like I said, 78-ish% of the atmosphere is made up of this molecule, nitrogen, N2, which is just nitrogen, okay? So N2 just means it's two nitrogen atoms bonded together, okay? So it's actually nitrogen in the air is found like this, okay? So you rarely ever see just a single nitrogen atom by itself. It's typically two nitrogen atoms bonded together by a really strong triple bond. And we're not going to get into the different kinds of bonds. That would be more chemistry, and this is biology. But just know that, you know how atoms are bonded together. There are different strengths of bonds. Some bonds are stronger than others. And the bond that is in nitrogen is really, really strong. Atmospheric nitrogen, that is, N2. It's really, really strong. So the thing is that plants on the ground, even though they're surrounded by all this nitrogen that's in the air, they cannot use a single bit of the nitrogen in the air. It's like being surrounded by an ocean, but not being able to drink any of the water. That's how plants are with nitrogen. So how do plants get the nitrogen? Well, the nitrogen has to be what we call fixed in a process called nitrogen fixation. Okay, so before plants on the ground can use all this nitrogen that's in the air, it first has to be fixed. And to be fixed means that it has to be converted into a form that the plants are able to consume. Okay, think about it like if you go to Chuck E. Cheese. I haven't been there in a long time. I don't know if anybody still goes there. In fact, I think they filed for bankruptcy, but that's a side note. My point is, you go to a place like Chuck E. Cheese, they have all these games and you have cash, but the games don't accept cash. Okay, so your cash is no good. You have to first take the cash to the counter, and some underpaid teenager who could just not care less will give you some tokens in exchange for your cash, and then you can use the tokens, okay? So what we just did is like fixation. We took money, that's perfectly good, and we exchanged it for a form that can be used or accepted by the machines that you want to play the games on, okay? We just had to convert it into another form, and then we could use it. And that's what fixation is, okay? So before the plants can use this nitrogen that's in the air, it has to first be fixed. And what fixes it? Well, there are two things really, that fix it, okay? So one thing is actually, you may be surprised, is lightning. Lightning is one of the things that can fix nitrogen. In other words, turn this nitrogen that's in the air into a form that the plants can accept. But once that happens, the nitrogen gets fixed, and then it gets taken down to the surface by drops of rain, and then it absorbs into the ground that way, and the plants can soak up the nitrogen through their roots. That's the only way plants can get nitrogen. They can't just breathe it in from the surface. They have to soak it in through their roots. So the nitrogen has to be in the ground, and that's why we have to fix it first. So we put it in the ground, and then they can soak it up. So lightning can do that during storms. And then the nitrogen will fall down to the surface in a raindrop. Another thing that does it, and this is the main thing that does it, are these things called nitrogen fixing bacteria. So lightning and bacteria are basically the two things that do most of the fixing of nitrogen, or the converting of nitrogen from its atmospheric form up in the air into a form that can be put into the soil and absorbed by the plants through their roots. And once the bacteria have fixed the nitrogen, the plants use it, but whatever doesn't get used, there are other bacteria that take that nitrogen that's in the soil, the nitrogen that the plants did not absorb, and they do what we call denitrification. Okay? So denitrification is performed by these bacteria, which we call denitrification bacteria. So bacteria can fix nitrogen and put it into the soil, or other bacteria will then unfix the nitrogen and put it back into the air. And then other bacteria will fix the nitrogen and put it back into the soil. And then other bacteria will unfix it and put it back into the air. Okay. And occasionally you get a thunderstorm, there's lightning, and then that helps out too. But for the most part, it's these bacteria. Okay. Another thing that puts nitrogen into the soil is animal waste. Okay. So cow urine, or in this case it's a cow, but it could be any animal. Okay. And also solid waste, poop. Okay. Those things can be broken down by fungi and bacteria that are in the soil into this thing that we call ammonia. Okay. And that's called ammonification. Now, ammonification is not one of the things that, is really stressed in terms of having to know it for high school biology. But I am just going to mention it because it's important to know that animal waste will also be turned into what we call ammonia. And then that ammonia will be turned into a form that, nitrate is what it's called, a form that plants can use and absorb through their roots. And if it doesn't, then the denitrifying bacteria will then unfix it and put it back in the air. Okay. So that's how it works on the surface. So just remember, bacteria and lightning put it in, they fix it, and then other bacteria unfix it. Same thing with animal waste. It's turned into ammonia and then into nitrate, and then plants can use it. Okay, so that's how it works on land. But what about in the ocean where there is no 78% atmospheric nitrogen? Well, let's look at that. All right. So this is an example that I work on my grammar of how the nitrogen cycle works in the ocean. Okay, so like I said, on land, most 78% of the air is nitrogen, but down here there is no air. So then what do? Well, nitrate is the magic molecule. Okay, So this is the same on land. Okay, so when I say that nitrogen has to be converted into a form that plants can use, well, that form that plants can use is called nitrate. Okay, so the same molecule is in the ground on land in the soil. Okay, and that's what plants absorb through their roots. So this is what you want it to be able to be consumed by producers. And on land, that's plants, but in the ocean, there are plants, but mainly it's phytoplankton, okay, and other producers as well. All right. So these guys right here are what we call phytoplankton. The word phyto means plant, okay. So these are plant-like plankton. That's why they're called phytoplankton. And the reason why they're like plants is because they do photosynthesis like plants do on land, okay? But just like plants on land, they need nitrogen, and the way that they consume nitrogen, they can't just go eat nitrogen. It has to be in this nitrate form, okay? So they eat the nitrate. That's how they get this nitrogen. These oxygens, don't necessarily aren't the important part. The nitrogen in the middle, that's what they're really after. Okay, so they eat that. And then, all these phytoplankton, they eventually die, they decay, right? And as they decompose, they go through a process of decomposition, just like animals and plants do on land. And that waste gets turned into ammonium, which is just like the animal waste that we were talking about on land. Okay, so instead of the cow peeing on the ground, this is plankton and fish, also fish, dying and decomposing and turning into ammonia that way. Okay, and then bacteria. This is a bacteria, right? They fix. This whole thing is fixing, so they are fixing this ammonium into nitrate, which is the magic molecule, and the process starts all over. Okay, so when there is no atmosphere in the ocean, the main source is ammonium, which comes from dead and decaying plant and animal matter in the ocean, along with urine from the fish as well, because fish do urinate just like land animals do, okay? So just remember the importance of nitrogen to plant life. Without them, there would be no producers, and the whole food web would collapse if there was no producers, obviously. It works on land, it works in water. Fixation is when we're turning it into a form we can use, which is plants or producers, I should say producers, can use. That's fixation. What we're fixing it into or converting it into is nitrate. The nitrate gets used, and then the waste gets recycled back into the system to be converted back into nitrate again, and the process starts all over again. So that is the nitrogen cycle on land and in water. I hope you learned something.